Good afternoon, ladies and gentlemen. My name is John Belquist from Intelligent Concrete. Wanted to talk today about scanning electron microscopy. A scanning electron microscopy is a technique used throughout a lot of universities, throughout the academic arena, to look at what the eye can't see. It's great for metals, it's great carbon fibers. Now with new types of chambers, you can do or conductive materials. You can do waters or stuff with fluids in it. But we're often asked, today we had the conversation, is scanning electron microscopy valid for the practical world, for selling commercial products? And before we get into it, I think a definition of what scanning electron microscopy is warranted. And I've got a photo here that we took. It looks like a really pretty mountain range, some really nice high detail. And we took this photo in a Joule. It was a pretty old Joule. I think it was like a 1996 scanning electron microscope. In a scanning electron microscope, we'll take a really, really small sample and bombard it with a bunch of electrons. Those electrons bounce off, and without going into the whole mechanics of it, a secondary electron bounces off that we capture onto a screen, and it creates a black and white topographical image. And that's what we're looking at right here. And it's really freaking cool to look at. But the question is, what the hell does it mean, and how does it relate to the real world? So I want to take a step back, or take a step away. This is a concrete sample, and we've got our technician standing here who did a wonderful test on the sample, and it's the ASTM C779 Procedure C abrasion resistance of concrete. And I'm just going to give a quick synopsis of this, and correct me if I'm wrong. We got about 9 steel balls rotating over a concrete surface with a bunch of water. There's a 26-pound force, something around there, pushing up from underneath, and what we're measuring, if you could see, is the depth of wear of those steel balls into the concrete surface. Over time. 20 minutes, 50-second segments, 24 segments, something to that jazz. And what you see here is this, what we call it a trough, but that's where the steel balls cut into, and that's what depth of wear we're measuring. So what I've included, or patchouli included in on this the spiel that I'm giving, is this scanning electron microscope photo of one of these troughs. And if you jump onto our website or some of our clients' websites, we've written articles about abrasion resistance of concrete. And, it's really hard to understand abrasion resistance of concrete because you have to look at so many different levels. And one of the things that we looked at in this scanning electron microscope was the trough itself and how this inferior concrete didn't hold onto aggregate. And what ended up happening, instead of like a work hardening or a polishing, you ended up having this rock or this sand being toured out of the cement paste and just that really wasn't English or any scientific jargon. Sorry about it. Sometimes words or sounds describe things better than words. So it looks like you had a piece of sand or rock or some type of aggregate just being drug over the surface, and not only do you have gouges in the cement paste, but you actually have these cracks that go from one of these gouges to the next one. And in a superior concrete mix design, instead of having this torn out surface, you would have a denser surface or a polished surface, something that almost looked like a work hardened surface. So again, the point of this was to help you connect the scanning electron microscopy, and again, the toughest part about scanning electron microscopy is, does it collect to the real world? And what we found with this scanning electron microscopy is we could identify what was happening to pastes that were giving us subpar results versus pastes that were giving us superior results. And we can do the same thing with admixture changes, with changes in the water cementitious ratio. So we did see a direct correlation, or at least connection, I think is a better word, between what was happening macroscopically versus what was happening microscopically. So yeah, if you have any questions, that was a talk on scanning electron microscopy, connecting it to the real world. I hope you had as much fun as I did. Thanks for joining us. Go concrete, beat asphalt.